Hey everybody! So there's a very interesting paper that was released, and it was released on May 25th of 2023. But I just saw it yesterday, so I don't know if it was just released in the U.S. yesterday. But it's called "Ghosts in the Minecraft," and the paper is written by a lot of research institutions, a lot of universities, Sense Time Research, Center for Artificial Intelligence and Robotics. And then at the very end, you can see it's sponsored and endorsed by the Chinese government itself. And Ghosts in the Minecraft, it solves the game of Minecraft essentially. So that's what the paper is essentially. Is that so? Right now, prior to Ghosts in the Minecraft, any sort of Minecraft agent that has been in existence, it's been able to solve Minecraft at to about 33%. According to the paper. And then so within this, Ghost in the Minecraft brings it from 33% completion rate to 100% completion. The very first Minecraft agent to ever complete Minecraft, period. And then they make a very interesting statement within this paper, and then they also they follow it with three sources at the end. So it's right here. And it says, Minecraft acts as a microcosm of the real world. Developing an automated agent that can master all technical challenges in Minecraft is akin to creating an artificial intelligence capable of autonomously learning and mastering the entire real-world technology. However, existing researches remain narrowly scoped. And then again, this is one, and they give three sources to this. And this statement is included in here. With approval from the Chinese government, with approval from all of these institutions, and this is exactly the statement that they very purposefully put in this paper and at the end. So, if you're reading this particular statement, it's literally saying that they're endorsing that this is essentially AGI, that they've created an agent that can solve an open source world and an open world and open reality, and that even if that open reality is a virtual reality, you can then apply that same logic to an actual reality and actually solve for it. And the way that this model operates very similarly off of another recent model that I showcased with regards towards Minecraft agents. And so I think that this shows just very explicitly that people are onto something with this with regards towards utilizing essentially LLMs to train themselves by utilizing and giving LLMs additional tools. So if you look at the method, the first thing that they do is they give it an LLM decomposer. Really simply, essentially what this does is it breaks down the prompt and the overall larger goal into smaller goals. So rather than giving the agent the complete the entire game of Minecraft, it's here's what you need to do in order to complete the entire game of Minecraft. Now let's break that up into thousands of individual goals, and let's go for the individual goals so that we can decompose it. And then so the first part of the model is to give the LLM ability to do that. The second part of the model is an LLM planner, and then I should note here and up front, all of this is text-based as well. So the other logic within this too is to give this all to the LLM within the language that it naturally understands, which is human language. And then rather than coding it out, give it to it in tables and text format. And then so that's what this is. And then so the LLM planner is essentially information about the environment. Like here is all of the equipment that you have, here's the equipment that you need, here are here's a map of the world, all of the typical things that you would look for within this. And then essentially gives it the ability to access and to retrieve and pull from that information and to utilize that information to help it to make decisions within the world. So the bottom line is it's taking it a step further from learning from its experiences, which has been the gap within AI agents within Minecraft so far, is that you can get them to learn from their experiences, but then learning from your experience and then also applying a tool that could be utilized based off of the experience, but you don't have any actual experience with that tool itself. That's been the gap. And then so this particular agent solves for that gap. And then the next thing that it applies and it gives it is a feedback mechanism. So essentially, as it goes through and then it makes decisions and then it makes errors, the feedback mechanism is essentially like a secondary agent. So a lot of this is driven by splitting out in this case it's ChatGPT 3.5 into two different agents. You have the user agent and the system agent. And then so the system agent provides feedback to the user agent when it runs into errors or mistakes or it needs help. So then it can restart back based off of that feedback. And then the system agent can generate its feedback based off of essentially everything that it's watching. And then so the next element that they put into it is a planning mechanism, which is essentially giving it to look forward into the future. So say for example that the agent needs or wants an item, but it knows that it will need it in the future, but not far in the future. For the planning agent allows it to keep that in mind, so that when it runs into things that it knows that it might not need for a long time in advance, it can actually account for and say, hey, I should pick this up, it's going to be useful in the future. Text-based memory is a big thing, and then this is also another thing that was directly in the last paper that I saw with regards towards Minecraft agents, giving it the ability to essentially take notes, and giving it it to be able to pull from text-based memory as opposed to code-based memory, as I think the extreme importance there. And then they also note that they put this directly in an LLM interface, and I'll show this when we go down. This is all LLM based, all prompt based. And then so they go through the experiments and then the results, and then the results are 100% completion. Is essentially what they show, and then they show that this is the prior success rates, and then prior to their model, and then this is what they were able to get up to. So fascinating, extreme advancement there. This is just essentially going over their model in the conclusion, and then so plus 47.5% success rate. So again, just massive improvement overall. Oh, I think the other big thing to note that they do highlight a lot within this paper is that the prior agents within Minecraft and how they're getting this 47.5 and what they attribute it to is that prior agents are utilizing reinforcement learning, and reinforcement learning has been around for a long time. I think a lot of people are familiar with that within AI. If you know anything at all about AI and machine learning, reinforcement learning is giving it positive or negative reinforcement based off of actions. But what we're finding more and more is that that's not how people think. People think based off of that reinforcement, but that there's a lot more to it. So that you need a reinforcement as a base, but that you can't rely on that base for much more than simple learning. And that's that's essentially kind of the ground that I think researchers are going towards more and more. And then in this particular paper, they claim that has gotten them to AGI. That's this very specific claim in this paper that has endorsement from the Chinese government. So going through just beyond their implementation details, they outline, and I'll link this paper in the description, they outline all of the prompts, the exact prompts that they use, so for the system and the user, and then exactly how they do it. So, for the system, you're an assistant, here's everything that you need. For the user, you're going to play a game. And then just they go down, and then all of the different elements, they feed in individual elements on top to for the text-based elements, the project planning, all of that, and it's all prompts again. So the LLM planner, it's all a prompt. Here it is for the system. It's essentially giving it everything all the instructions that it needs to complete the goal. Telling it how functions work, how to move, how to craft objects, giving it like what would be like a player help guide, giving that information to the system so that the system can then relay that information to the user if the user gets stuck in a certain area. And then also too, this is showing again, so it's all text-based. So if the user runs into a situation and the user is essentially constantly relaying their progress, their situation, what they're going through back to the system agent. And then so they'll relay through text, here's my current state, here's my current inventory, here's my environment, here's my goal, here's my plan, I'm running into a situation, and then the system agent can respond back, hey, let's revise your plan, let's do this, let's do X. And then so that's essentially breaking that down. As far as the memory goes, it's breaking how it breaks it down. They utilize specifically highlight here that they utilize ChatGPT 3.5 Turbo for all of this, which is pretty common that I've seen with these, either ChatGPT 3.5 or 4.0. I do think it's interesting that they were able to run this on 3.5, which means that the technology in this area is advancing, because the prior models that I've seen that are utilizing and being able to pull this off, they all relied 100% on GPT-4, and a lot of them made the specific statement that they couldn't do it with GPT 3.5. So the fact that this paper is able to do this on 3.5, I think is also significant. So as far as the memory itself, essentially what you can see is this is just a breakdown of how it gives it to structure the memory, and then like it's how it's structured is for the it prompts the LLM model to summarize its thoughts, and then to summarize its thoughts in a specific format, and that so that it can remember that information and then pull back from it, and the system agent can also utilize that information to help the user agent as well. Then essentially this is showing just the success rate and the completion, and then I think that's pretty much the end there. But so overall, this is significant for a few reasons. Starting off, just simplistically, I think that the improvement from ChatGPT 4 to 3.5, the fact that they're running on that is significant. The fact that there's so many researchers involved within this paper, I think, is significant. The 100% completion rate, like 47% advancement, is extremely significant. But I mean, to me, the most significant statement in this paper is this. Like, this paper was scrutinized and went through the Chinese government, the whole entire gamut, and then so for a paper of this caliber, as far as the amount of research that went into it, and the fact that they're including this particular statement as worded within it, I think is extremely important to pay attention to, especially as far as the wording, because just very explicitly outlining it, they're explicitly calling this an AGI agent. So I hope you guys like this video, and like and subscribe if you like this content. Thank you.